Hi everyone, this is Miss Huang. So today's do now is how do you locate, compare, and order integers and rational numbers using number lines? So we have different kinds of numbers. We have mixed numbers, we have integers, we have decimals, and fractions. So our TEK for today is 8.2b. Our lesson target is scholars will classify real numbers and approximate values of irrational numbers, locating its value on a number line. And the DOL is given two problems. Scholars will approximate the value of an irrational number, including pi and square roots, and locate that rational number approximation on a number line with 100% accuracy. As an intro to square roots, if you have a square object and you know what the area is and the question is asking for a side length, what you can do is just find the square root of that area. So this example with the smallest square, we know that the area is 4 square roots because there's 4 squares. And since we have the picture, we can see that the side length is 2. But if we didn't have this visual and we just knew that the area was 4 and we had to figure out what the side length is of a square object, we could do square root of 4. And to do that, we have to think backwards. We have to think what number times itself will equal to 4. And that's 2, because 2 times 2 is 4. The same thing for the square root of 9, which is 3. The same thing for the square root of 16, which is 4. So the square root of the area of the square equals the side of the square. So you have an activity to practice. You have to list out the perfect squares between 1 and 20. 1 squared is the same thing as 1 times 1, and that's going to be 1. 2 squared is 2 times 2, so that's 4. 3 squared is 3 times 3, 9. 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64, 9 square, 81, 10 square, 100, 11 square, 121, 12 square, 144, 13 square, 169, 14 square, 196, 15 square, 225. So I highly recommend that you guys memorize the perfect squares from 1 to 15. It'll make your lives easier. You guys can fill in the rest on your activity on the next slide. So as a review, irrational numbers are a type of real number, and they include non-perfect squares. So square root of 17, square root of 2, negative square root of 11, as well as pi. Rational numbers include fractions as well as decimals. Irrational numbers can also be decimals, but there's a difference. Rational numbers are terminating decimals, so decimals that end, such as 0.75, 0.675, or 0.2, as well as repeating decimals where there is a pattern of the repeating numbers, so 0.333 or 0.575757. An example of an irrational number decimal would be 0.135, 8, 7, 7, and the numbers continue. So it's a non-terminating decimal. That means it doesn't stop, and there's no repeating numbers, or there's no pattern of repeating numbers. So now we have to classify and write the following numbers in one of two categories, rational or irrational numbers. So -2 would be rational, 3/10 rational since it's a fraction, 7.1 rational since it's a terminating decimal, 2.4 rational, -2.2 rational, -5/6, that's a fraction, so that's rational, 0.333, that's a repeating decimal, so that's rational, 5.121212, that's also a repeating decimal since there's the pattern of the 1, 2. And instead of writing the repeating numbers, I'm just writing a line on top. Square root of 25 is a perfect square because 5 times 5 is 25. So this is a rational number. Square root of 8 is an irrational number since it's not a perfect square. Square root of 32 is an irrational number since it's not a perfect square. Negative square root of 5 is an irrational number, so not a perfect square, as well as square root of 12. 22 over 7 is a fraction, so it's rational. Negative 2.234, 324, 234. So yes, the numbers are repeating, but there's not a pattern that it's repeating, so it's going to be irrational. So I'm just going to write the first three numbers after the decimal, and then write dot, dot, dot. 1.2657 is rational since it's a terminating decimal, so the decimal stops. 1/9 is rational. 3/10 is rational. Negative 2/5 is rational. 0.1011011. So the 1 and the 0 are repeating, but there's not a pattern of the repeating numbers. So it's actually going to be irrational. Then we have 5.121212. And so since there's the pattern of the repeating 1, 2, that's going to be a rational number. The first IGU question is to approximate and locate the value of square root of 12 on a number line. And in this pink box, I give hints as to the steps. So step 1 is to find the closest perfect squares. Step 2 is to find the square of the number in between. So thinking about the perfect squares, 3 to the power of 2, or 3 squared, is 9. 4 squared is 16. If we did square root of 9, we would get 3. If we did square root of 16, we'd get 4. So that means that the square root of 12 is in between 3 and 4. And so step 2 was to find the square of the number in between. A number in between 3 and 4 is 3.5. That's halfway in between. So we have to figure out what 3.5 squared is. 3.5 squared is 12.25. So that means that the square root of 12.25 is 3.5. We're trying to figure out the square root of 12. So we know that it's actually going to be less than 3.5. And if we were to use our Desmos calculator right here, we have to click on the keyboard, square root of 12. We see that it's around 3.46. So it's about 3.46. So on the number line, if this is 3.5, 3.46 would be this red dot right here. And that means that the square root of 12 would be represented by this dot. Then there was a poll where you had to answer between what two numbers is the solution to the square root of 23. A was 4 and 5, B was 22 and 23, C was 5 and 6, D was 3 and 4. So the perfect squares that are closest to 23 are 4 and 5, so answer choice A was the correct answer. Since 4 squared is 16, and 5 squared is 25. So the square root of 23 would actually be between 4 and 5. This guided practice problem, or our we do, is asking us to approximate and locate the value of square root of 23 on a number line. So we have to figure out what perfect squares are closest to 23. So 4 squared is 16. 5 squared is 25. So the square root of 23 is going to be in between square root of 16 and square root of 25. So that means it must be between 4 and 5. Then the number in between 4 and 5 is 4.5. So we have to find the square of the number in between. So we're doing 4.5 squared, which is the same thing as 4.5 times 4.5, and that's 20.25. So the square root of 20.25 is 4.5, but we're trying to find the square root of 23, so we know it's actually going to be larger than 4.5. So we're going to use our Desmos calculator to do the square root of 23, and that's around 4.795. If we round it to the nearest hundredths place, it would actually become 4.8. And so to locate 4.8 on this number line, if this is 4.5, I would say 4.8 is around here. And that's the value of square root of 23. So the square root of 23 would be around right here. Now we have to approximate and locate the value of negative square root of 23 and square root of 17 on a number line. So we know that square root of 23 was between 3 and 4. So that means that the square root of negative square root of 23 is going to be between negative 3 and negative 4. And we found out that the square root of 23 is 4.8. So negative square root of 23 is about negative 4.8. And square root of 17, to figure that out, we have to figure out the perfect squares that are closest to it. So 4 squared is 16. 5 squared is 25. So the square root of 16 and the square root of 25 would be the boundaries with which square root of 17 would be. And so that means square root of 17 would be between 4 and 5. If we use our Desmos calculator to figure out square root of 17, we see that it's about 4.12 if we're rounding it to the hundredths place. So to locate it on the number line, let's say that this is negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So negative 4.8, if this is negative 4.5, let's say negative 4.8 is right here. So this is going to be negative square root of 23. And 4.12 is, if this is 4, let's say 4.12 is around right here. So this is going to be square root of 17 on the number line. So we approximated the values, and then we located them on the number line. For this we do problem, it says we have to approximate and locate the value of negative square root of 15 and square root of 18 on a number line. So first we have to figure out the closest perfect squares. So 3 squared is 9, 4 squared is 16, So that means that square root of 15 is in between. And because it's negative, that means it's between -3 and -4. According to the Desmos calculator, negative square root of 15 is about -3.87. Then for square root of 18, 4 squared is 16. 5 squared is 25. So square root of 18 is in between 4 and 5. According to the calculator, it's about 4.24. So we've approximated the values of the square roots, and now we have to locate them on the number line. So let's say that this is -4, this is -3, -2, -1, 0, 1, 2, 3, 4, 5. So negative square root of 15 is around -3.87. So if this is -3, -3.5, -3.87 is around here. And so that's where negative square root of 15 is. And then for 4.24, if this is 4, let's say 4.24 is around here. So this is going to be where square root of 18 is. For this I do problem, it reads, Francis completely covered a square wall using 87.5 feet squared of wallpaper without any overlap. Which measurement is closest to the side length of this wall in feet? So this goes back to that intro to square roots where we know the area is 87.5. And to find out what the side length is, we're going to have to square root 87.5. And so we're going to think of the closest perfect squares. So 9 squared is 81. 10 squared is 100. And so that means that the square root of 87.5 is in between 9 and 10. If we look at the answer choices, we see that only C is in between 9 and 10. And then if we find out what the square root of 87.5 is, it's around 9.35 feet. This we do problem reads, Carlos painted a square wall with an area of 127.5 feet squared. Which measurement is closest to the side length of this wall in feet? So very similar to that last problem, we're given the area, which is 127.5. Then we have to find the side length, so we're going to square root it. So we have to think of the closest perfect squares. So 10 squared is 100. 11 squared is 121. 12 squared is 144. So the square root of 127.5 is in between the square root of 121 and 144. So that means that the side length must be between 11 and 12. If we look at the answer choices, C is 11 feet. And if we were to find the square root of 127.5 on a calculator, we would get 11.29. Okay, your you-do is Sheila cleans a square window with an area of 49 feet squared. Which measurement is closest to the side length of this window in feet? So you're thinking about what number times itself would equal to 49. You're finding the square root of 49. and the answer is 7, so the correct answer was D. That was a poll. Then we have, is every real number an irrational number? Answer choice A was yes, answer choice B was no. The answer was no, because every irrational number is a real number, but real numbers don't have to be irrational numbers because they can also be rational numbers. Then students answered the question, what is the difference between a rational and irrational number? And lastly, you all had to do your DOL. The Google form is linked here, and so click on it to answer the 2 DOL questions. Thank you so much for following along today's lesson, and see you in the next math video.